So we're now in chapter 10, geometric figures. And then section 1 this week is what I would call plane figures. And to get going here, there's some basic concepts we kind of have to accept to do this geometry. And the basic concepts are the idea of a point. It's just a position in space. And it's kind of an abstract idea because we make this thing called a point, like I make that tiny little dot. Sometimes I'll make it bigger to make it more visible. And a point is really kind of a zero-dimensional thing, which is weird, zero dimension. Versus the idea of a line. Line is straight. Often we think about a line in a plane. I can draw a line with the help of this tool here. So that's a line. That's a line. And some other things about the idea of a line is that we think of it as going on in each direction. So although I stop, theoretically the line keeps going. And where a point, we say, has zero dimension, a line is one-dimensional. And what I mean by that dimension is that I can measure it. So I can measure length on a line. So here I have a line. Theoretically, it goes in each direction, but I can pick a starting point, maybe right there, call that point A, and I can pick an ending point, maybe over here, point B. And if these lines on my grid are a ruler, then this is 1, 2, 3, 4, 5, 6, 7, 8 units long. And here I'm just calling them units, but sometimes we measure things in centimeters and sometimes inches or miles or yards or feet. So all the different units of measure. But as far as a line goes, when we think about a line, we measure its length, and it really, its thickness is not measurable. So although it has a thickness when I draw it with ink digitally or on paper or pencil graphite, we kind of ignore that it has a width and just consider it having a length. And so that's why we say it's not on dimension, one dimension. It's one dimensional because we can measure this one dimension of it called length. And a point technically has no dimension, it's just a place, it's just a location there. And that idea of having zero dimension, or this idea that a line really only has one dimension and doesn't have a thickness, that's a weird mathematical idea, and it doesn't really exist in reality. So a lot of the things we deal with in geometry, it's this idealized world that mimics nature around us, but it's not quite the same thing. So it's a special part of math, and it's got these basic concepts we kind of have to accept, again, and the most basic are the idea of a point, just this position in space, 0 dimension, and this idea of a straight line that goes on in each direction. And it has a length that we can measure between any 2 points, but it doesn't have a thickness. So I can measure length, but there's no thickness, no width. So point, most basic. Line, we can make a line if we have a couple of points. And then the next basic idea is the idea of a plane. Plane we think about as a flat surface. Like a piece of paper. My screen here. And when we draw a plane, often it's going to be drawn as this kind of skewed rectangle, like we're looking at this surface, a table from an angle. So from any angle but straight down on a table isn't going to look like a rectangle, it's going to look more like that in its perspective form. So this is a symbolic version of a plane here. And a plane, kind of like a line, theoretically continues out in every direction. And we're only going to do a tiny bit of work with planes right now. The main reason I need to mention them at the moment is the type of geometry we're focusing on in the beginning here is plane figure geometry. We'll move into 3-dimensional geometry later. And with plane figure geometry, all things live in a single plane. So what we're going to do next is just kind of play around with some tools in a geometry program. So I'm going to show you the program and then I'll put a link to it, or you can just look it up. Geogebra.org is the site we're going to go to. And they have multiple things we can play with. So you may have used GeoGebra before in another class, may not. You might have used a calculator in some math classes called Desmos. So Desmos came after GeoGebra. So GeoGebra has a graphing calculator. Where you maybe in a math class graph something like y equals 2x plus 1. There's all kinds of stuff you can do it graphically. They also have geometry tools built in here that we could play with. Now, usually I don't like to use the graphing calculator with the geometry, but they work well together. I'm going to go back to the home page on GeoGebra here. And what I'd rather do instead is just go down and get GeoGebra's geometry version here instead of the graphing calculator. And they start off with just some basic things I can play with. I have a move tool I can play with here, a point, a line segment, a line, a polygon, and circle with a center. So I just kind of want to play around with this here to get some of these basic ideas about plane geometry. So the screen in front of us is the single plane that we get to work with, this flat surface. And in that flat surface, we can put points. So I click the point tool and it says, select position or line or function or curve. So we can put points on things if we want, but I'm just going to put a point on the plane here. When you put a point down, the first thing it does is say, hey, let's call that A. And if you grabbed another one and put it down, it would call that B. So it's going to name things for you automatically. If you don't like the automatic naming, you can turn it off, but you could keep it on. The reason I like this better sometimes is occasionally the grid on the graphing calculator just becomes a distraction, and I don't need to know the location of each point. I just need to know where the point is. So for now, we're just going to play with the basic geometry version. So again, from the Geogebra homepage, I got down from the calculator and just grabbed the geometry version of it. And they're all related. It's not a big deal. Segment. Segment is a line between 2 points, and it just ends. It just stops there. If you use the segment tool, it doesn't have to have 2 points already. So I could put a segment anywhere I want by just having the segment tool selected and then clicking one and then clicking another point. Segment's different from a line. So I mentioned before, a line in geometry is something that we think keeps going on forever. And so if you use the line tool and you plot 1 point, then it's waiting for you to plot another point, waiting for me to click somewhere. And notice it just continues off the screen. And if I grab the move tool and I start just looking to see, hey, where'd that line go? As I click and drag, the line just keeps going in that direction. So we've got a line segment, we've got a line. Polygon, we'll get to those in the next section. I might as well do one here. That's any kind of flat shape that's made of straight edges. So for example, a real simple triangle, or you could make some kind of four-sided shape. That's called a quadrilateral. And the shapes could do something like overlap themselves. Talk more about the difference between a shape that overlaps itself like this one and one that doesn't like those. Circle is another kind of plane thing. Here it says circle with center. So let's see what that does. So whenever you click on one of these tools down below, it'll tell you something. Select the center point and then another point on the circle. So if I click here, that marks the center, and as I move out, it's waiting for me to click to say, okay, I want that circle right there. So I'm just playing around here. If I want to reset this, then I can just go up to that main menu and clear it. I could save it, and I could also share it. Now, if you want to save or share stuff, then you have to have an account. So I signed up for an account. It's pretty easy. It's free. It's no big deal. So just for fun, go to a new window. A little bit of work with Geogebra here and there. And I select sign in. If I don't already have an account, I can create one. And I could use something like a Google account to make my Geogebra account. That way I don't have to worry about a username and a password. So that's what I recommend you do. If you use Google or Facebook, then use Google or Facebook to sign up with Geogebra for account. The cool thing there is when you make something in Geogebra, you can then share it with me. So if I wanted all of you to have this pretty picture I made there, then I could just go to share. Wants to give it a name. And then save, and then it'll think for a second, and it'll say, oh, here's your share link. So you can just copy that and then give it to somebody in email or a Zoom chat. And so then you would have this to play with. So it's kind of sort of like sharing a Google Doc. And as of last year, like somebody else could edit your Google Doc, you couldn't edit somebody else's Geogebra file online, but they may have changed that. So we'll have to check that out. So I'm going to clear this and start over. And I'm going to take a look at more. So they have a whole bunch of different things you can do on the screen. We'll take a look at constructions later. We'll look at measurements a little bit today. And then the line tools we can play with. We'll do more with circles later, and polygons, and transforms. And there's even more tools if you don't find the one you want. And they pretty much have a tool for just about anything you want to do. clear. It should go back to the basic one, maybe. Oh, no, I remembered. Oh, less there, and then less again. Yeah, so you could just go back to the basic set of tools, or the medium set of tools, or the full set of tools. All right, so basic ideas. We got a point. If we have 2 points, we have a line. I could put a line through those 2 points, but just by reselecting them. We could have a segment, which is part of a line. So here I have a segment AB. On this line, I could make another segment CD, or I can make a segment somewhere else. Now, cool thing about GeoGebra is everything is editable. And there's a couple ways to edit. You could point to something and then right-click on it. And then you could duplicate it, fix it, show a trace, or do settings. So I'm just going to go to settings here. And in settings, you can change some things like their color. So I have this segment CD I clicked on. And sometimes it's hard to click on the right thing. And I can show you a way around that before. But I could change its color to make it stand out. So maybe I want it to be red. And so I can see segment CD highlighted in red sitting on top of line AB here. Segment EF down there. There's another big idea that's in this section, the idea of array. An array starts at a point and then goes through another point and it keeps on going. So line goes in each direction, a segment ends on each side, an array continues in only one direction and it can continue in any direction you want. And if you want to change the direction, change the second point by clicking and dragging. Similarly, you can change where it starts. So everything, almost everything is adjustable in GeoGebra, which is kind of fun. All right, so let's summarize some of these ideas, then we'll come back here and play. So on the screen a moment ago, I had a couple points like that, and I had a line going through them, and I labeled, say, one of the points A and one of the points B. So sometimes when we name things in geometry, a line can sometimes just be given a letter, like maybe I could call that line M, and if I were to make another line, say through those points, I might give it a slightly different name, like maybe this one I'll call M. So usually it's a lowercase letter to name a line. Or we'll use 2 points on it. So maybe that one has AB and this one has the point CD on it. Maybe they intersect here at the point E. So line L, I could also call AB, and I would put a line with arrows on it over the top to indicate that it's a line. And any 2 points would work. So line L is line AB, and I could also call it line AE maybe. And we put that line with an arrow on top of the 2 letters to indicate it's a line that goes on in each direction. Even for a segment, like maybe I'm just going to have a segment here for CD, and maybe I'll call that N. So N, to indicate it's a segment, it starts at C and ends at D or vice versa, and the line on top of it gets no arrows. It's just a straight bar. So this would be a line segment. And if I had, say, a ray that started at B and then kept going through A, like that, maybe I gave that a name like lowercase r, then to indicate it's really array, I could do starting at B, go through A, and usually with array, it's the end point that goes first, and then the point that's somewhere inside in the middle of the array there. And then I just draw a line with an arrow like that. This would be array. And the points on the line, 2 points are collinear. Linear points. One of two things. They could be any points on the same line. Or just any 2 points. So for my first idea here, points A, B, and E are definitely collinear because they're on the same line. So example of that first idea, point A, point B, and point E, all live on this line R, so they're collinear. Any 2 points I pick, so like A and C, even though I didn't draw a line through them, I could, so they are collinear, even though the line's not drawn. Because through any 2 points, we can make a line. Points that wouldn't be collinear here. It's easy to pick 3 points that don't line up. So A and B line up, but C does not line up with A and B at the same time. So not collinear. Example would be like A, B, and C. 2 points always line up. 3 points, it depends. Do they already live on the same line or not? If they clearly don't, then they're not collinear. So A, B, and C, there's no way they could be collinear. Similar idea, coplanar. Any 2 points are going to be coplanar. And it turns out any 3 points can be coplanar. After 3, it gets a little trickier. So have you ever had a chair or a table that wobbled a little bit and it had 4 legs? And what happens is 2 of the legs settle down, and then either it goes to the 3rd leg on one side or the 4th leg on the other side. So at any time, you could have 2 or 3 points touching, but if the 4th point isn't just right, it's not going to be in the same plane. So after that, to be coplanar, the points must be on the same plane. And kind of the relationship to kind of think about there is think about a wobbly table. Or chair. Anything with 4 legs. If the legs aren't just the right size compared to the floor, then it's going to wobble. And it will wobble by either kind of like balancing on 2 legs momentarily or sitting on 3 legs, and the 4th one is up in the air. So if you have 3 points, you're guaranteed a plane. 2 points are always coplanar, but you're not guaranteed a plane. And one way to think about that is, let's see if I can draw this. So let's say here is one of my planes. And then I have another plane, choose a different color. That's coming through like this. And then these 2 planes intersect on this line right here. So if we're going to say color the green plane in here, what you would see As you could see the green, at least this part of the green plane over here. And you can see it over here too, but then that blue one would be blocking it from our sight. So like maybe the blue wall is blue is a wall and the green is the floor in some building. Looking into it. And so if I pick 2 points, say on this line where they meet, those 2 points are in the blue plane and they're in the green plane. So that's what I meant by if you have 2 points, although they are going to be coplanar, there could be lots of planes they're in. If I pick a third point over here in the green one, these 3 points are coplanar in the green plane. But any point on the blue plane is not going to be coplanar to these 3 together, if I called them A, B, and C. And we'll play more 3D stuff later. But mostly what we're going to do in this section is just focus on just 2 dimensions, a single plane playing around with shapes in there.